Welcome to today's deep dive. Have you ever watched a massive live esports tournament and just wonder how they seamlessly cut between dozens of different camera angles without a single glitch?
Yeah, you just sit there expecting television magic.
Right. I mean, we expect that visual perfection, but the reality behind the scenes is, well, incredibly complex.
Oh, absolutely.
So our mission today is unpacking this technical spec sheet for something called the Kiloview KVW-BASIC NDI core. We're going to cut through the heavy jargon and explore the fascinating invisible infrastructure that actually powers modern live video and broadcasting.
Right. And the foundation of this whole system is NDI, which stands for Network Device Interface. It's basically a technology that allows you to send high-quality, low-latency video over regular computer networks.
Okay, so it's like the ultimate digital traffic cop.
Exactly. And this specific software, the core R part, actually stands for Control, Organize, Route, and Everything.
I love that. So instead of massive heavy cables running literally everywhere, it connects disparate pieces over a network, like conference cameras, mobile phones, computers.
Massive television production systems.
Yeah, but I mean, how does it switch between them so cleanly?
Well, it relies on automatic discovery of local NDI devices. You just plug a camera into the network and the system instantly sees it.
Oh, wow.
Yeah, but the real magic is the seamless switching. Historically, you'd need separate, highly expensive frame synchronization hardware just to
align the video.
Right, perfectly align two video sources before you could cut between them without a glitch. But this software handles that synchronization natively.
Let's visualize that mechanism for a second. It's kind of like cars merging onto a busy highway. Usually you need a stoplight.
Which is the old hardware.
Exactly, to pace the cars so they don't crash into each other.
Yeah.
But this software acts as a frictionless zipper merge, syncing the video frames perfectly at full speed without needing them to stop or slow down.
That zipper merge takes immense processing power, though. I mean, it's actively copying and amplifying that massive data stream with a delay of one single frame or less at the matrix end.
Wait, okay, they call this the basic version, but
there's nothing basic about it.
Right. I'm looking at these specs, and it's wild. It demands an x86 4-core CPU, at least 8 gigs of RAM, and a gigabit Ethernet setup pushing at least 4 gigabits per second.
Yeah, it's heavy duty.
On top of that, it asks for a Linux Docker deployment. It explicitly waves people off a standard Windows setup.
Well, standard desktop operating systems are just incredibly resource-heavy. Docker allows the software to run in an isolated, hyper-efficient container.
Oh, I see.
Because when you are processing up to 16 maximum NDI inputs and outputs simultaneously...
Which is actually unlimited if you're using Kiloview or NewTek sources, right?
Correct. Any operating system bloat will cause lag. You are moving full 4K resolution at 60 frames per second.
That's a ton of data.
It is. Processing that much high-resolution data with essentially zero lag requires server-level architecture.
Okay, but if the technical demands are that intense, taking a $599 gamble to see if your network can handle it seems, I don't know, a bit steep.
And this is exactly where we see broadcast infrastructure shifting from millions of dollars of hardware to accessible, tiered software ecosystems. Kiloview actually offers a 15-day free trial limited to 4 inputs and outputs. It serves as a sandbox.
So you can test that network routing magic and verify your server can handle the load before committing.
Precisely.
Plus, even factoring in the 10% off discount code available on their site, this $599 basic version is really just the entry point to test scalability.
Because the ecosystem scales way up.
Yeah, to a pro version for $999, all the way to a heavy-duty max hardware system with 64 inputs for $7,999. They even make compatible converters, like the U40 HDMI and the N5 SDI.
Right, to pull legacy video gear right into that modern network. Replacing rooms full of specialized, expensive switching hardware with scalable software that can route dozens of 4K streams simultaneously is just a massive leap. It really highlights the sheer scale of how far network video has come.
It completely redefines what a broadcast studio even looks like.
Yeah.
So we'll leave you with this thought today. If an entry-level $599 system can seamlessly juggle 16 different 4K broadcast streams with only a single frame of delay, how might this rapidly accessible, high-bandwidth video technology completely reshape how you experience live events or, even your everyday remote meetings in the near future?